Okay, so this is 14D, which is just a continuation of networks or graphs. But the difference with this one is each edge actually has a number on it. So this number could represent um, kilometers, it could represent time, how long it takes to go from town A to B, and so on. Okay, so that's pretty much what 14D is all about. Still continuing networks, but now each edge has actually got a number to represent kilometers or time usually. Okay, and these two are just examples. Okay, of what a weighted graph looks like. All right. Now, the whole point of weighted graphs is usually they're trying to find out how, the shortest path or the shortest time or shortest distance to go from one place to another place. Okay. There's two ways to do it. The first one is just by inspection, and then there's Dijkstra's algorithm. Okay. So the inspection, if you look at this one, shortest path between O and C, you might have to do a bit of trial and error. So O is there, okay, and you're trying to get to C, but you're trying to get there the shortest time. So these numbers could represent kilometers. So you can see clearly here that the shortest way would just be going from O to B and then B to C. So that'll be O, B, C. That'll be the shortest path. And if these numbers represent kilometers, you would say that'll take you 14 kilometers. Okay, which will be shorter than any other way. Same thing with this example here. You're starting at O and you want to go to C. So there's a few different ways. All you're doing is trying to find the shortest way by inspection. So I would say this one is probably the shortest way. So 12 and 13. So that'll be O, D, C, and that'll be, if these numbers again represent a kilometer, it could also represent time, how quickly it takes to go from different towns. But let's say kilometers, that'll be 25 kilometers to go from O to C, and you're going to go via D. And again, it'll be the shortest way to get there. Okay? Alright. Now the other method is Dijkstra's algorithm. Okay? So essentially now this one can be a little bit tricky, but this is good when you got a more complicated network and it's a bit harder to do it by inspection. So if you look at this one here, you're starting at X, okay? And you go to, so you from X you've either got C or you got A. Now what I'll do is next to C, I'll write the numbers, that's 3. Next to A is 2. So if I had to choose, I would choose A. Okay? Now, if you go to A to D, you can it'll be 2 and 3, which is 5. If you go the other way, 3 and 4 is 7. All you do is just choose the smaller number. So I'm going to put a 5 there. Just to know that'll be 5, let's say kilometers, 5 kilometers. And then when you're at D, you can either go to F, which is 10, or you go to E, which is another 3, so that'll be 8. So obviously you can see the path here. I'll fill it out at the end, but you can sort of see the path here. You're going from X, A, then you're going to D, because that's shorter. Then you're going to E rather than F, because E is shorter. When you get to E, then to go down, it'll be 8 plus 6 is 14. 10 plus 6 is 16. You choose the smaller one, so I'm going to write 14 here. Okay? And then once you get to the end, here in G, if you go down, you go down to 17. And if you go across, you go to 15. So I will choose 15 here. Okay? And then when you go down, it'll be 15 plus 4 is 19. 17 plus 2 is 19. So actually, you could actually choose two different alternate paths. So one will be through G, H, and Y. Other one will be G, I, and Y, and they both end up with 19. So that'll be the shortest path in terms of distance. But if you were going to actually highlight the path, it'll be from there, 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 there. And when you come to the bottom, you can actually choose two. So I would choose this one here. And see that? That'll be the shortest path to go from X to Y, and that'll take you 19 kilometers. Okay? And if you're gonna write that out, okay, you would just write down, so this will be, I'll put it on the top here, you would just write down X, so we go from X, oh, wrong color, alright, so we'll go from X, A, then D, then E, and then G, and then I've chosen to go through H and Y. Okay, and that's the shortest path. And that's Dijkstra's algorithm. Okay, and this is better when you got the more complicated net graph and you're not sure how to get from the start to the end. Let's look at another one. Okay, so again, this one here, you're starting at X. Okay, so you can go to G, that's 9, so I'll put 9 here. And then you go to E, which is 10. So I'm going to choose the 9. Again, I'm not going to highlight until the end because sometimes another option might be a bit better. Alright, so when I'm at G, I can either go to A, which is 9 plus 15, which is 24. Okay, so let's write that down. Okay. Now, when I'm at 10, see that from 9 to 14, that'll be 23. But 10 to 12 is 22. So I'm going to choose, just put down the lower number, which is 22. So in this case, even though G is the shortest at the start, actually XEF is shorter than XGF. Okay, so that's why at the end, I'll only fill out the path. Then once you get to here 24, to get to B, you add 10. That's 34. Then from A, you can from E you can go to D, which is another 14, so that'll be 24. Okay, and then from D you can get to Y, which is going to be 59. Okay, and then from F you can go to 12 more, which is 34, but I've already got a 24 there, so you always pick the shorter one, so that's done. 22 and 13 is 35. I've already got 24 there. So again, I'm not going to change that. 24 and 12, that's 36. So I'll put 36 here. Okay. 24 and 15 is 39, but I've already got a 36 there. 36 and 12 is 48, but I've already got a 34 there. Okay. 34 and 14 is actually 48, which I've got a 59 there. So I can actually cross that out and put down 48. So there you go there. So the shortest distance is going to be a 48. And then all you need to do is work out how I'm going to get there. In your book, they've got a table format. You can copy, you can follow that. Or I know here that I'm going to start at X. Okay, so I'm going to start at X. Alright, so we're starting there. Okay, and then all you need to do is work your way to 40, but just remember to go the shortest. So you can look at these numbers here. So X, E, F, that'll be the shortest way to get to F. Okay, or the other way is I can go up the top there. Okay, that's also going to give me 4. So essentially, there's a few different ways you could probably get to the end. That's still going to be the shortest way. Okay, so you can go X, E, F, and then you can go back to A, B, and Y. So there are a number of different ways. I'm just going to choose this way. It doesn't matter. X, E, F, 24, 34, and 40. As long as you just want to get to the your final destination, the shortest different way. And these numbers will help. 10, 22. Actually, no, sorry, I made a mistake. So let me rub that out. Because if you look here, 22 and 13 is not going to get you to 24. So pretty much you need to make sure you follow the numbers and they add up. Okay, so I'm not going to, so actually even though it's 22 here, okay, so that's 22 right here. Okay, it's not going to be, I can't get that way because then I have to add 13, which is not going to give you the shortest way. So how do I get this? So it'll be, it's actually 9, 24, yeah, just be over the top. So the shortest way, don't make it complicated. Just go with your first instinct and choose, as long as you get to the end in 40. So actually it'd be best if I go like this. There, 9 plus 15 is 24, plus 10 is 34, and 48. And that'll be the shortest path to go from X to Y. Even though if I go down the bottom, I get to F shorter, right? But then the next step is going to be longer because then that's going to be 13 more. So the quickest one is definitely the top. And that'll be my shortest path. All right. Final example. This is known as the Chinese postman problem, which essentially means that in this case, you start at A and you cover every edge, okay, and you return back at A. So essentially what we got ourselves here is a Eulerian circuit. Okay, so we covered this in previous exercises. What Eulerian means is you cover every edge once, but you end up where you started from. Okay, now if you look back at your previous note, in order for Eulerian circuit to exist, every edge, every degree, all of these degrees here must be even. So see that they're even, but see these two are not even. So what you need to do is you need to create yourself another edge. This is the most important part about this one. If you want to create a Eulerian circuit, every degree must be even. And if it's not, your job is to create another edge so it becomes even. So if I create another edge here, and there you go. Now can you see? Instead of 3, that's got a degree of 4, and that's got a degree of 4. And essentially you wanna do the shortest path. Okay? So essentially you just want to cover every edge once. And that's what I added there. I added the shorter length. If I cover every edge once, it'll be 132. But because this has not got all even degrees, I've had to create another edge. So I'm going to have to add 15 to that as well. So really, we already know that the shortest distance is going to be 147. Now your job is to start at A. Okay, so we're going to start at A. Okay, we're going to start at A, and all you need to do is start at A. All you need to do is create yourself a Eulerian circuit that covers every edge, but you want to end up at A. And there might be multiple answers, but this is one answer. There's A, B, B, then you can go down to C, then you can go back to A, then you can go to F, then you can go to D, okay, and then D, and then C, and then back to D. Okay, see that? I've covered that twice. And then from D, you can go to E. And then from E, you can go to F. And then from F, you can go to O and back home. See that? I covered every edge once, and that's the minimum way to get around. But just remember, you need to create yourself and the extra edge at every degree is even. Okay, let's look at another example. This is the final example. In this one here, you've got the shortest length. Once again, you add them all up and you got 44. Okay, now if you look at this one, we've actually got 2 odd degrees. So what you need to do is you need to make it from one side. So all you need to do is just add another edge there. So I'm going to add one more edge there. Okay, so I'll add another edge here for this one here. So add an edge, and I'll add another edge here. So now what happens is instead of 1, you've actually got 2 coming out of that, 2 degrees. In this one, you've actually got 4 now. And in this one, you've actually got 6. So see that? Every degree is an even degree. So therefore, the Eulerian circuit will work. And all I've done is I've added an extra 3 and an extra 5. So which means on my shortest length is going to add another 8. So it's going to be 52 distance to get around. So all you need to do is work out a way where you're starting at A. Okay, you say you start at A and you finish at A. Okay, so this is, again, this is one option. Okay, so we're starting at A. Okay, which is there. So I'm starting at A. All right, I'm going to go to A to B, which is down here. Then from B to C. Then from C to D. And then from D to A. D to A. I'm sorry, D to E. and then from D we can go to F, and then from F we go to A, and then from A we can go to S. And I think I made a mistake. Let me just quickly redo this again. So let me rub this out. Let me actually rub this whole thing out. Okay, so let me start again. So let me rub this out. So all we know is, we got an extra edge here. Okay. Alright, so we've got an extra edge here. And we got another one edge. And all we're doing is we're starting at A. Okay, and we're gonna make our way all the way back to A. So again we'll do it again. So we got A to B. That's one. Then we can do B to C. That's another one. Then from C to D. That's another one. Okay. Then here I got a couple different ways. So I want to cover every edge only once. So I can go to D to E. Yes, if I want, actually I might go, yes, I might go D to E. Okay, and then E to F. And then F back to D. Then back to A. And then we're going to go across here, back, and up here, and back. And there you go. That's you have all the aim is, sometimes you might make small mistakes, just need to be a trial and error, but aim is to cover every single edge once, and you start and finish at the same spot. So in other words, it's just the same, basically a Eulerian circuit. But the most important thing is you want every single degree to be even. If it's not, it will not work out. A Eulerian circuit will not work out. Okay, and that is 14D. Thank you.